All right, today we are pulling back the curtain on what might just be the most important, but maybe least glamorous, part of data mining. I'm talking about data pre-processing. This is the essential groundwork, the unseen craft that turns messy, raw data into a solid foundation for finding those incredible insights. So let's get into it.
So let me ask you a question. When you think of data mining, what's the first thing that pops into your head? Is it some super complex algorithm, maybe a powerful machine learning model crunching numbers? Well, what if I told you that the most critical step, the one that literally makes or breaks an entire project, happens way before any of that cool stuff? It's true. It is all in the preparation.
So, here's our roadmap. We're going to go on what I like to call the data transformation journey. We'll start with the basics, the foundation of mining. Then we'll get into describing and measuring the data. After that, the art of data cleaning. Then we'll tackle integrating and reducing data, transforming it, and finally visualizing it to get those amazing insights. All right, let's dive in.
Okay, first things first, let's establish why any of this really matters. Think about it like this. You would never, ever build a house on a shaky foundation, right? Of course not. Well, in the world of data mining, your data is that foundation. So getting the preparation right isn't just a best practice, it's absolutely everything. And to really get why this prep work is so vital, you have to look at the end goal. What are we even trying to do here? Data mining is all about finding knowledge that is useful, valid, unexpected, and understandable. And let me be really clear, you cannot get any of those things, not one, from messy, poor quality data. It's just not going to happen.
So, the very first step in our journey is inspection. Just like a craftsman looks over their wood before they start carving, we have to get our hands dirty and really examine our data. We need to get a feel for it, understand its quirks, and start figuring out how all the different pieces actually relate to each other.
And one of the most fundamental ways we measure our data is by looking at two simple ideas: similarity and dissimilarity. Now, this might sound super basic, but it's incredibly powerful. Similarity just tells us how alike two things are, on a scale from 0 to 1. Dissimilarity, as you can guess, does the exact opposite. These simple measurements become the building blocks for way more complex tasks down the line, like clustering and classification.
Now for the part that, let's be honest, can sometimes feel like a chore, but it is actually a totally transformative process, I'm talking about data cleaning. This is where we take a messy, inconsistent, all-over-the-place data set and turn it into a high-quality masterpiece that's actually ready for analysis. So what does a clean data set even look like? Well, it really boils down to hitting 5 key targets. First, is the data correct? That's accuracy. Are there missing pieces? We need completeness. Do we have a bunch of duplicates? That's where uniqueness comes in. Is the data still relevant, or is it from ages ago? That's timeliness. And finally, does it all make sense together? That's consistency. This isn't just some random list. Think of it as our quality control checklist. If you fail on even one of these, your whole project could be on shaky ground.
The process for cleaning is actually pretty methodical. It's a simple 2-step loop that you just repeat. Step 1, you audit your data to find the problems, all those little discrepancies. Step 2, you choose the right tool, the right transformation to fix them, and you apply it. And then you just do it again and again until your data meets all 5 of those quality goals we just talked about. Okay, so our data is clean. What's next? Well, often we need to combine it with data from other places. That's called data integration. And once we've done that, we usually need to focus in and trim the data set down to what's most important. We call that data reduction. But as you can imagine, just mashing different data sets together is rarely easy. You run into all kinds of challenges. For example, the way you define a customer in your sales database might be totally different from how the marketing system defines a customer. Are they the same thing? You also have to wrestle with different time zones, clunky old legacy systems, and sometimes even real-world factors that limit what data you can even get your hands on. And that brings us to data reduction. Imagine you have this massive, complex data set with hundreds, maybe thousands of variables. It can be completely overwhelming. The goal here isn't just to blindly delete data, it's to simplify it. Essentially, we want to replace one huge, messy table of information with a couple of smaller, more manageable ones that still capture the essence of the original. It's all about keeping the story while cutting out the noise.
We're almost there. We're at the final shaping stage. Our data is clean, it's integrated, and it's focused. The very last step before the real fun begins is to transform it into the perfect format that our data mining algorithm needs. This is where we put the final polish on our raw materials.
Now, the really crucial thing to get here is that different algorithms need data in different shapes. That's where these transformations come in. We might use smoothing to get rid of some random staticky noise. We could use aggregation to summarize data, say calculating total weekly sales from a bunch of daily figures. Normalization is huge for scaling different variables to a common range. And discretization lets us turn a specific number, like someone's age, into a broader category, like young adult or senior.
And finally, after all that meticulous cleaning, integrating, and transforming, we arrive at what is often the most rewarding part of the whole process. This is the final polish, the step that lets us see the results of all our hard work: visualization.
And let's be really clear about something. Visualization isn't just about making a few pretty charts to stick in a presentation. No way. It is a powerful analysis tool all by itself. This is the step that takes all of that data you've worked on so carefully and finally turns it into a clear, understandable story. It's how you actually reveal the patterns that you've worked so incredibly hard to uncover. Which brings me to a final thought. We've walked through a lot of systematic steps, right? Checklists, defined processes. It all sounds very scientific. But choosing the perfect transformation, or knowing exactly how much noise to filter out, well, that often comes down to intuition, to experience. So, I'll leave you with this question to chew on. Is this unseen craft of data preparation more of an art or a science?